Okay, hello again. This is the second time we're meeting today. So I would like to do two problems. Let's start with the first one. So we have a more glorified version of the slider crank mechanism that we did last week, and that is this. Okay. So if you look at the individual parts, there is a piston. There is a crank that I would like to make it look like that. Here is my connecting rod or the coupler. And this whole thing that you see here, so that little piece plus these little two carry-ons are the track. Okay. Now I also have a pin here that I will put through that hole, through that connecting rod, coming from the other side, and basically holds the pin and the connecting, or the piston and connecting rod together. Now, this for mechanism purposes, for let me see that, for kinematics purposes, this is not necessary, but I will throw it in here so that you can see that there will be a complication that we have to fix. In other words, I could have done this problem without this pin. However, I would like to include the pin to see what problem we're going to run into. And then we worry about the second problem later on. Are there any questions? In my opinion, this is probably the most involved assembly that you are doing in this course. And, yeah, that's pretty much it. It's still very simple, but I'll show you the steps. All the steps are going to be shown. So let's start with the product file. New product. Say OK. Immediately save it. I don't want to be here. I want to go to assembly design, as you can see. So file save management, save as, desktop, new folder. I'll call it one single cylinder. It's going to be on the top. You don't have to fool around, look for it. All right. Let's start with the piston. So I'm not going to worry about dimensions whatsoever. So insert new part in there, and this is going to be my piston. Right click, properties, piston, and piston. Okay, let's make it. Double click on this. You go into part design. On a convenient plane, on that vertical plane, I will sketch. Okay, something that looks like that piston. So I'm going to draw a geometry like this. And I'm sure you know what these things are. These are for the piston ring that you put metal gasket there so that, the thing does not leak or whatever. Okay. Now, I would like to I can make the top flat, but because of the thing that I have here, I'll make the top a little bit curved. So let me draw a line here first of all. You'll see what that line is for in a second. Okay, and I'm going to make this line into a construction line right there, and then I'm going to do an arc. Where's that circle? Arc. For example, from this point, actually, just a second. So let me do a spline. How about the spline? So going for example, where's the spline here? Right, is this the spline? Yeah, from this point to, come on. This point to that point. Okay, I don't want this thing to be a construction. It's going to be a curve. And I want this thing to be tangent to that. Okay, so that line, that construction line, control that curve. Let's make them tangent to each other. All right. And okay, this is too high, so let me move it a little bit up. That's fine. Okay, and I'm going to close this because I want to shaft that to get the piston. Exit. Notice that I made that construction line because I don't want it to participate in my creation of the piston. So shaft, that sketch about the z-axis, 360 degrees, and there we are. Okay. Now on that plane, on one of these planes, so let me put this thing in isometric view. On this plane, I will sketch a little rectangle because I want to have a cutout here to be able to this. See that? I want this cutout here. Okay. So exit, pocket in both direction. More. There. Okay. And I want this thing on the other side too. So mirror that. So where is the mirror? Let's see now. This is this mirror. Mirror. That pocket with respect to that plane. There we are. We have it on both sides now. So on that face, I will sketch a little hole because that hole is going to carry the pin. So let's make it a circle. Again, dimensions I'm totally ignoring here. Exit and make a pocket all the way through. All the way to the last. Is that the last? There, you can see it, see through it. And I'm going to remove material from inside of this. And that can be done by the shelling operation. If you look at the toolbars, one of them says dress up features. Okay, and there's one that says here shell. So you take, it says, let's read this thing carefully. Face to remove is this. And the amount of removal, so let's default inside thickness. Let's make this thing 0.1, see how it looks like. This is good, except that I didn't want this piece either. So let's go ahead, double click on the shell. And also as faces to remove, let's put this face also. And then we say, okay, there we are. There's my piston. Done. Let's go ahead. Save everything.
Okay. Can you repeat the shell step, please?
Shelling operation?
Yes, please.
Okay, so you go to part design. It's in part design. Where's that piston? Under dress up feature, there is this icon here which says shell. And when you do that, it's going to ask you what faces to keep, what faces to remove. So I remove that top face and I remove that hole. And it says how much wall thickness you want to give it. And I put 0.1. And then that's it. Okay. So that's what it was.
And how does it know when to stop shelling?
It goes until it reaches the end on the other side. I mean, basically, there's something wrong here, though. Wait a minute. I've got to find out what this thing is. I don't think I went probably far enough. It just removes the material, leaves the 0.1 until it reaches the end. Yeah.
Okay, thank you.
Yeah, there's something wrong here. I don't know. What is this? Maybe it didn't go all the way through. Okay, I should have said up to something. When I did the pocket here, I'm not sure. Hang in there. Pocket to the last, and that's okay. There's no problem there. Let me deact. Oh, I did two of them. That's what happened. I wanted to show you something, and that's why I created two of them. That's what it was. So that's what it was. Okay, good. When you asked me how to do it, I clicked on that to create another line shell, and it was all screwed up. Fine. Now, let's go up here and insert the pin. Let's do the pin. So insert, new part. Always say no. The pin. Right-click properties. By the way, if I went too fast over this shelling, I know that, but really you should go and practice on it on a box. You know what I mean. So pin and pin. Okay, let's make it. So on a convenient plane, on that vertical plane, on that plane, I will sketch. Here's a sketch. Sketch. I'm too lazy. Project that circle on it instead of drawing a circle that size. There we are. And then exit, pad it, mirror extent, and go to a particular plane, for example, up to this plane. I think you have to do the other side too, maybe, I'm not sure. Yeah, I think you have to do the other side too. Up to plane. Let me see what happened here. Yeah, so actually double click on this, and on the second tab you go up to the plane, the other plane, and that'll do it. There's the pin. Okay, good. So save it, save everything. Where's that floppy? Right there. Insert the connecting rod. So insert, new part. Say no. Conrod. Right click properties. If I were you, I would sit back, relax, watch this, and go and do it yourself at your leisure with the video in front of you. Don't get stressed out. Conrad, that's really not the purpose of these lectures. Double click. Let's make it. So on that plane, I will sketch. Notice that I'm making them in place because it's easier for me to do it. Okay, so let me project that circle. The conrod is going to, this pin is going to go through that conrod, you know that. So project that circle. There we are. And I don't need this stuff. I can, if you know, I can hide them. Let me do the other one. Let me hide the other one. Hide the pin instead. There, you see that? Okay, and let's do the rest of the connecting rod. Nothing fancy. I mean, connecting rods are a lot more complicated than what I'm doing, obviously. You're going to clean it up in a minute. Terrible. Okay, let's zoom in, make sure everything is symmetric. Maybe this circle, control that circle. We make them concentric. Okay, and I have a feeling that these are symmetric. If not, we'll take this circle, control that axis, we make it coincident. Yeah, and by default these are probably symmetric now. I don't know, this, control that, control the middle axis, make it symmetric. Yeah, everything looks good. Okay, now we need a little circle here, a little hole here, because the crank is going to go through that. Through the, not the crank, the shaft, I meant, the shaft. Exit, pad it symmetrically by, how about 0.2? Let's see how it looks like. Yeah, it looks good. That looks good. Okay, good. Save it. Save everything. Not like that. Save the assembly. This is the lazy way of doing it. Okay, let's make the shaft. How about that? The shaft. So on this plane, I will. Oh, wait a minute. Let's insert it first. Insert a new part in there. Always say no. And call this thing the crank. Right click, properties, crank. Crank. Double click on it. On a convenient plane, on that vertical plane, I'm using this vertical plane to make all these things, the pin, the connecting rod, you know, I'm going to sketch. Okay, why don't I project that circle? Good. Let's make exit and pad it. Yeah, that's good. And on that face, I will sketch, because I want to do something like this, okay? I want to do something like that, okay? So on that face, I will sketch. Hey, you know, we'll clean it up. Don't worry. Okay. There's nothing to clean up here. So, yeah, exit, pad it. That's too much. 0.3. Okay. On this face, I will sketch, because I want to get this guy for you. These guys. This guy, actually. What is that? Oh, this guy. I want to get this guy for you. So let's draw a circle. Yeah, okay, something like this. Exit, exit, pad it. Yeah, let's make it one. Let me see. Let me make it 2. Okay, now I want exactly the same thing on the other side. No problem. Mirror it. Mirror. Mirror with respect to, what's it saying? With respect to this. There we are. Go up. Save everything. Where is the save? Okay, let's do what do they call it? The track, or I call this thing what? The block. Okay. So insert, new part. No. Block. And where is it? Part name. There. Block. Okay, let's go make it. Double click. I don't know, I'm going to make it like this. So on that top plate, on that horizontal plate, horizontal plane, yeah, I'll sketch. So I'm going to project that circle. There we are. Exit. Well, actually, you know what? Let's go back there. I don't want the whole thing. because you can't see what's going on inside. So let me draw a line here and clean it up. Okay, so there's the line. I'm going to trim it, quick trim, because otherwise you can't see what's happening inside of that track. So get rid of this, get rid of that. Oops. Get rid of the bottom piece. I don't know, one of them. Is that better? Oh, I wanted the line in the other direction. Terrible. No, my line was in the wrong direction. So let me undo all of these. Undo, 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 undo. Okay, the line I wanted vertical, because otherwise I can't see inside of that. Okay, do the same thing. Trim that guy, this guy, that side. Very good. Exit. Okay. I want to do one more thing. Let's go back here. So let me draw something like that. A rectangle. We'll clean it up. We'll clean it up. Okay, like this. Okay, so let me see for a second. Yeah, like that. Let me see for a second. Let me look at the thing that I want to make. Yep. Okay, so I had a bad sketch here. Let's go fix it. Okay, so this is a bad line here. I didn't want this. Let me clean it up. So from here to there, and from here, where is that place? Where is that place that they meet? Right there to there. Vertical. Vertical. There we are. We'll just do another quick trim. So another quick trim, get rid of this. What's it saying? See, this goes. This goes. Why is this thing not going? No problem. Just there's more than one way to skin a cat. Okay, okay, okay. Don't do a quick trim. Just get rid of this. Close that curve. Okay, exit, 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 add it. Okay, so you go up, 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 and there you go down, 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 down. Oh, go down, 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 down. Now look, I can go all the way down and make a hole here and put this thing in it, but I decided not to do that. I decided to do something else, and here's what I've done. Say okay? That is the piece that I was trying to do for you. Now, for these two little rings that belong to that, it's easy. So I go on that face, I will sketch, project that circle. There we are. Exit. Okay, so that's this. Just a second. We need to make a hole here. So let's look at the view from the front. Okay, is this the right one? There. Circle. Now do you see why I said don't worry about doing it with me? It's totally useless to do it like that. Concentric. Excellent. Make this thing a little bit smaller. Exit. Exit. Pad it. Not that much. 0.1, 0.3, I don't know. Good. And you want this thing on the other side? Mirror it. So mirror this thing, this pad, with respect. This is the one. See, underscore means that underline means that this is the one that's acting. Just mirror it with respect to that plane on the other side, not the whole thing. Damn. Actually, let's try again. Mirror. Where's that mirror? With respect to this. It did the top piece too, but it doesn't matter. It's okay. Don't worry about it. It did that thing right here. Okay? So save everything. Okay, let's catch our breath. Are there any questions? Don't worry, you'll get it. All right, so let's fix the track. This is the track or the block. Okay, so anchor that guy. Move everything out of the way so that you can assemble properly. Okay, so let me move this thing here. Move that thing there. Move that thing there. Where's the pin? Well, the pin is in hiding. I hid it, remember? Right there. Hide and show. Hide and show. Okay, sometimes this doesn't work, so go to the tree. Where is the pin? Pin. Right here. Hide and show. There it is. And zoom out. Okay, let's start putting it together. First thing, I'm going to put the crank in here. So coincidence between that axis and the axis of this little ring here. And the vertical plane of the crank and the vertical plane of the block. So coincidence between the vertical plane of the crank and the vertical plane of the block. We say, okay, update, it's going to go there. Good. Let's put the connecting rod on that shaft. So coincidence between this axis, and the axis of the hole in the connecting rod, and coincidence between the vertical plane of the connecting rod and the one for the shaft. Now, where's the one for the shaft? They're sitting on top of each other because of the way I constructed it. So let's do it from here. The YZ plane, XZ plane of the shaft, not the shaft, what is it called? The crank. This is the con rod and XZ plane of the crank. Update. There we are. Okay, let's put the pin in there. So coincidence between the axis of the pin and the axis of, well, I can do it here. I can do it like, well, let me put the, it really doesn't matter. Let me, yeah, fine. The axis of that, and coincidence, did I do the axis and axis? Can't remember. What did I do? Where are the restraints? This last one was axis to axis. Yeah, that's good. So coincidence between the vertical plane of the pin and the vertical plane of the connecting rod. Con rod. This is a crank. XZ. Say OK. Update. There we are. Now let's put the piston in there. So coincidence between this axis and the axis of the pin. Okay? And coincidence between the vertical plane of the piston and the vertical plane of the pin. Where's that pin? Pin. Right there. And OK. And update. There we are. Now, To check to see if our constraints are okay, you go to move, check this box. See this box? See this box? Check it, and let's rotate it about the axis of the shaft. Okay, look. This is a good sign. There's only one caveat. There's only one problem. It's a good sign, but there's one problem. I'll show you. That's not the problem. Wait. Okay, good. The problem is that if I take the pin and tilt it, if I take the pin, where's that guy? If I take the pin and not the pin, the piston, and rotate it, for example, about this, you see, it's not going to go back where it is. I have to make the axis of the pin and axis of that not the pin, the axis of the piston and the axis of the block coincident. Axis of the piston and the axis of the block. Update. Good. Excellent. So save everything. Okay, let's go ahead and see what happens. So we go to digital markup, DMU kinematics, magic wand, new mechanism, mechanism 1, auto create, say okay. So let's think about it first. You're at the stage where you should tell me what joints you have. Revolute here, revolute there, revolute for the pin and the connecting rod, and a prismatic for this guy, for the piston. So I expect three, I don't know, three, there's 1, 2, 3, three revolutes and one prismatic. Let's check it out.
Professor,
actually, yes.
For the piston head and the block, like the cylindrical covering of it, can we like make a coincidence or a contact between the outside curve of the piston and the inside curve of the block? Is that something we can do?
Did you say contact?
Yeah, I'm saying it like arbitrary. To be honest with you, I really don't know what kind of connection would be able.
That contact, I don't advise you to use it unless you feel more comfortable with it. Now, first of all, right now, the pin is only a cylindrical. It's not prismatic because I'm not sure. Let's check it. Don't use contact. My suggestion is don't use contact unless you're absolutely confident it's going to work, okay? So don't use contact. And we can discuss this thing later on. So look.
Yeah, well, just a general question.
Yeah. Okay, so let's see now. We have see that piston and the block. All I did was axis to axis. That's why it came out to be. What is it called? Cylindrical. Okay. Now I can make it prismatic. I can make it prismatic by saying plane, for example, a plane of the piston and a plane of the block to be coincident. And this came out to be prismatic because of what I just told you. Now, the problem is that you have one extra degree of freedom. And that one extra degree of freedom is because this pin can actually spin about its axis. Because all we did, the pin and the connecting rod, see the pin and the connecting rod? We said axis and axis, and the vertical plane and the vertical plane. That makes this thing a revolute joint, and that's why it can turn. The 2 degree of freedom is mainly because one degree of freedom is because of this pin sitting there loose, it can spin, and the other one is, of course, the crank can turn. So here's what I'm going to do. To fix this, I'm going to take the joint, the revolute between the connecting rod and the pin, which is right here. See that? This? I'm going to delete this. And then make a rigid joint between the pin and the connecting rod. So rigid, we have never used that, right there, between the connecting rod and the pin. There we are. You see, if you don't do this, if you don't prevent the rotation of the pin, it becomes an extra degree of freedom. But we know that you won't let rotation like that happen. Okay? So what are we going to do? We're going to make the crank turn. So where is the crank and the block? Right there. Angle driven. 0 to 360. Say OK. Mechanism can be simulated. Can I do that manually? Yep. What is that? Manually. 1 degree of freedom, rotation of the crank. There we are. There we are. We can make a simulation. Cartoon. No physics. Insert. Rewind. Anything but one. This is the same slider crank mechanism that I did for you. It's just that it's fancier. And you can specify the speed of the crank and then find out what is the acceleration of the block, not the block, the piston, because those acceleration are needed to do stress analysis of it in a different course, not in my course. You're done with stress analysis here. So I don't want to do physics anymore. I mean, I don't want to do the physics of this. We have already done it with the slider crank. Are there any questions?
Yes. So for the degrees of freedom, you might have said it before, and I wasn't paying attention. So are we always aiming to get a degrees of freedom 0?
You know, if you want to animate it, but 0 doesn't necessarily mean it's going to be what you want to do. For example, if this thing was completely, these parts were completely rigidly welded together, degree of freedom will be 0. It's just that it doesn't move. 0 is a good place to start. But getting a 0 does not mean you're going to get what you want. If you don't get a 0, you have a problem. I mean, if it's a single degree of freedom, and you don't get 0, you have a problem. But getting a 0 does not mean it'll do whatever you want. That's the thing. Yeah. Okay, so let's move on to our second problem. Please look. Don't be, I don't know, intimidated with this. Okay. It's just that I did it for you quickly because you have to see the steps. Then you go and slow it down and watch the video properly. Okay. The intention was not for you to be able to sit there and replicate what I'm doing, because that's not going to work if you're doing this for the first time. Okay. All right, let's kill this thing. If you have any questions, let me know. You don't have to do it now, but you can send me an email. You can MS call or not MS Teams or Teams call me. All right. Okay, so let's move on. Second problem. I'm going to make this thing for you. Basically, it's a very simple problem, nothing complicated. And I'm going to show you how I will do the part. These parts I could have done it before, but on purpose I didn't do it because I want to show you something. Okay, there is these two blocks are going to go inside of that track. One in there, one in there. You can see that, and then there is this bar is going to go. They've got 2 pins that are going to go into these holes, and then when this thing turns, or when this block starts to move, what happens is the tip of this rod will make an ellipse. That's why it's called ellipse generating mechanism. Okay, so let's go here. We have enough time. Of course, watch the steps. Go and do it yourself if you want, with properly watching the video. Okay, save this thing. File, save management, save as, desktop. Actually, let's move up here. Okay, is this yours? Section, or you guys section 2? Okay, so let's go to desktop. What did I do? Okay, I'll make a folder. So new folder 1 dash. You guys are. I'll have an ellipse. Ellipse. Okay, good. Okay, good. Let me make this thing the base first. The base looks like that. Okay. No dimension. I'm not worried about dimensions because dimension is just slows us down. But in all likelihood, people hire you to do dimensions and make real parts. So insert new part in there. I'll call it the base. Right click properties, base. Any one of you that has questions about these issues, you can hang around after the lecture. I'll be glad to entertain your questions and go through them with you. Double click on that plane. I will sketch. Again, dimensions are not critical, are not important to us in this problem, so I'm going to do it like that. Excellent. Okay, so let me just make sure that these, although it's not necessary, but I'll make them the same dimension. So 10 and 10, how about that? 10 and 10. Just so that it's a square, that's all. I want it to look like a square. That has nothing to do with the problem. Exit, pad it in the other direction. Let me actually make this thing a little bit bigger. 1. I'll make it 1.5. 1.5. Okay, good. On that face, I will sketch. There are different ways of doing it, but this is how I am going to do that. So I'm going to draw this thing. This is going to be the path where those blocks are going to take. Okay. And just so that I have an idea of what these sizes are, I'm going to make this thing, what is that? Make it 1. I'll make it 1. 1. Okay. Exit. Exit. Pocket by 0.5. Let's see how it looks like. Is that good? That looks good to me. 0.5 down. Okay, actually, let me make it. Yeah, 0.5 down. That's good. Good. And I want to do exactly on the other side. So let me use the circular pattern. Instead of me going and doing this thing again, let's say instances and angular spacing, 2 of them 90 degrees apart. Reference is that the z-axis. What is it that I want to pocket? Not pocket pattern. I want to pocket that pocket that I made right there. Hallelujah. Okay, good. You want to do it differently? Oops. No problem. You want to do it differently? No problem. Go and draw that thing and make another pocket, etc. All right. So this save it. File save. Let's make our block. And by a block, I mean these little guys. Then they're the same thing. So I'll make one of them and use it repeatedly, twice. It's not repeatedly. So insert a new part. Say no. Right click. Properties. Block. And block. Where is it? Block and block. Okay. Let's make it. All right, so on a convenient plane, on that horizontal plane, I will sketch a square 1 by 1. Remember, I put a dimension 1 here and then, pocketed 0.5 because I just want to get a nice looking block, that's all. So this is going to be 1. It has nothing to do with these sizes. This is a problem will work with other sizes. So 1. Okay. Let's do a circle here because I want to do a multipath. Right there. Actually, we don't have to do multi-pad. I need a hole in there. If I do a pattern right now, there's going to be a hole in there. So that's fine. And I'm going to go 1 up. Okay. And save it. Save. Save. And because I saved it, I can use this again as an as an existing component. Insert existing component. It says go find it. It's not right there. It is not right there. It is in ellipse right there. See that block? Because I saved it, I can use it. It's going to bring it and put it on top of this. There's going to be 2 on top of each other. So let me translate this thing in the X direction. There we are. Okay. And because I'm lazy, that rod, I'm going to make it like this. So well, first of all, save everything. Insert, new part in there. You say no. And this is the rod on the top. Right click properties. Rod and rod. There we are. Rod and rod. Say okay. Excellent. Let's go make it. So, this is terrible. Lazy. So on that plane, I will sketch. Why don't I project these 2 circles? Project this. Okay, and project the other one. Good. Now I can look at the view from here and make the rest of the rod, which is just a rectangle. Like this. There. And guess what? Multi-path. Because if I want to get pinned there for cosmetic purposes, I'll do a multi-path. This one is the little, probably one of these. Which one is it? Is it this one? What's this? Which one is which? Oh, this is the rectangle. So let's make this thing point, I don't know, point 0.3. How about that? Okay. This one, we make it 0.6 or 0.7. And is it there? 0.7. The other one, 0.7. I hope I didn't screw up. Where did it go? Oh, multi-path. Terrible. I screwed it up. Multi-path. Let's see now. That one, oh, this one should have been 1. I can't remember which one was which. This one is that circle over there. So I want that thing to be 0.7. Okay. This one is this is the rectangle that I wanted. I'll make it to be 0.3 and the other one 0.7. Look, I don't care how you do it, just do it. So save it. You're almost done. Save it. Okay, let's move these, put the constraints in there. So let me move this thing like that. Okay. All right. So first of all, we're going to anchor the base and then put these blocks inside of that track. So coincidence between, for example, this face and that face, and coincidence between this edge, and that edge, and update. It's going to jump in there. Let's put this other guy in the other track. So coincidence between this face and, I don't know if it's, helping you turn it around. We don't have to do that. And coincidence between this edge and that edge. This is going to become a prismatic joint, by the way. Both of these are going to become prismatic. Update. Excellent. That's okay. Don't let it bother you. Don't let it bother you. You can move this thing. It is a prismatic joint, so I can take this thing and there we go. Okay. And now put these pins inside of those holes. So coincidence between this axis and one of these axes, and coincidence between top plane and this plane. We may have to flip the arrows. So yeah, we have to flip the arrows. Update. Update. Okay, now the other one, I don't have to do the face-to-face because of the dimension. All I need to, an access to axis. I mean, you can do face-to-face also, but it's not necessary. There. So what we should get is two prismatic, one revolute, one cylindrical. Let's check it out. Check this box and say move this thing, I don't know, rotate. So move this thing about, I don't know, that line. Okay. Move it means rotate it. You see? Okay. Good. Say okay. Let's go to the digital mockup. DMU kinematics. Get the magic wand out.
You said there's one revolute and one cylindrical?
Yes, because for one of them, I made axis to axis and the plane to plane also, top plane of the block and the bottom plane of the rod. But for the other one, it was not necessary
axis,
to do that. Yeah. I mean, just did axis to axis, that becomes cylindrical. Because I didn't do the faces. The faces are mating just because of the way I made it. There's no constraint there. Okay, check it out. I mean, I always say, I also say things that may be wrong, but let's check it out. Two prismatic, one revolute, and one cylindrical. Prismatic, cylindrical, revolute. Okay, let's make one of these revolutes angle driven. So for example, let's make, I don't know, or make this angle driven. It doesn't matter. I'll make one of the revolutes angle driven, 0 to 360. Mechanism can be simulated. I know, I mean, that it can be done because otherwise that assembly would have not lied to me. Okay, now let's create a simulation because I want to show you the trace of this. The claim is that the trace of this point is an ellipse. So first you create a simulation, basically a cartoon. Drag it, insert it, change it to anything but one, rewind it. You can play it continuously. There. Okay, so we created our cartoon. Now I want to get the trace of this. What do I have to do? What is the thing that I have to do to get the trace of this point?
Trace a vertex?
Yes. But what do I have to do first? You're right. I mean, obviously this is what I want, but what I have to do something first.
Create a point.
Oh, I'm sorry, say that again? No, the vertex is already there. You don't have to create the point. I was looking for the answer. You got to compile it.
Compiler.
Create a replay.
Yeah, if you don't compile it, you can't get a trace. So anything but one. First you compile it. Oh, wait a minute. Maybe I don't have to compile it. Maybe trace will work actually. Never mind. Let's try it. Forget about compiling. Delete this. Trace. Let's see. I forget. Yeah, see. Yeah. So I think you have to compile. Okay. Anything but one. And now when I say trace, it's not going to complain. See that? You have to compile. Element to trace out is this point. You don't have to create a point if you don't want to. I mean, if you want some other point, then create it. But I want this vertex. This vertex, I'm claiming that it's going to be an ellipse. There we are. Okay. Okay, so save this thing. File, save management. File, save management. Save as. In that folder. Is that the right folder? Yep, that's good. Trace. Now that I saved it, I can bring it. I can close this thing and bring it in the assembly. So or the mechanism. So file. Let's to insert existing components. Because we saved it, we can go get it, bring it in, just like any other part. This is the trace. Open. There we are. And if you play the replay, you'll see that it will go, it will traverse that path. If the point, if the middle pin is halfway between these two ends, it's going to be a circle. That takes care of, I went 6 minutes over time. Okay, folks, any questions? I'm going to stop the recording here, but if you have any questions about this problem or the one that I did, I'll hang around for, I don't know, 10, 15 minutes, and then we can discuss it if you want. So I'm going to kill this.